So we said that every class, every Java file has to have a class that's public. That class has to have main. So main is where the code starts executing from. Notice that there are some things that are a little bit grayed out, and those are called comments. So this line of code is not going to be checked by the compiler. This is just a comment for us human beings to understand. So one of the reasons we would write comments is for us to remember some code, like the purpose of some code, or for other human beings who might be reading our program to understand what this is doing. So I might have comments like, ask the user for how much they make an hour, calculate their wage, write their salary to a file. So these are comments for us human beings. These are not checked by the compiler. If I have any spelling errors in them, the compiler is not going to check them. So the comments are for us human beings to understand the code, what it's doing. There are two types of comments. There are comments that start with the 2 backslashes. This is just a one-line comment. So if I press enter here and start typing, you'll notice that this is not grayed out. So the comment ends when the line ends. There's another type of comment, and it's similar to the one that's at the top, where it starts with a backslash asterisk. So I might come here at the beginning of my program, put backslash asterisk, and right when I press enter, you'll notice that NetBeans put the ending, which is the asterisk backslash. And here I might put things that tell anyone who opens this file the purpose of this file. So I might write, author Ibtisam, so anyone who has questions knows who to contact. I might say this program will calculate how much a user should get as a salary. And notice when I'm pressing enter, everything here is a comment. So this is called a multi-line comment. It spans multiple lines. You start it off and the comment continues until you actually close it. After that, everything I'm writing now is not a comment. Comments are good to write at the beginning of the program so that you can remember what you did, what the purpose of the file is, for other people who might open your file to know what this code is doing. Another nice thing that you might want to write is updates to the code. So if you made an update, let's say on August 7th, I made an update and I fixed asking the fixed code to check if wage is negative. If I made some fix to the code, or I made some addition to the code, I might want to write a comment for myself here. This is useful in real programming environments because sometimes when you make a change to code, you might accidentally break something else. So if your program was working fine and then someone says, comes to you and says, hey, your program was working fine, but when I ran it on August 9th, for some reason, this broke. And you're like, why did it break? And then you go look at your code and you see a comment that on August 7th, you fixed something. So sometimes when we fix something, we might accidentally break something else in code, especially when your code is huge and it spans like thousands of lines. So it's a really good idea when you're making changes to existing code to make a comment for yourself at the top of the file of all the changes that are being made. And this is to help you figure out mistakes in the future. Now, before we continue, I want to talk about RAM and memory, computer memory. So remember last time we talked a little bit about RAM, where the computer is going to be using some space in RAM to store information. Now, how is information stored in RAM? So if I'm writing, an essay and I write my name is not going to be stored in RAM as letters like this because the computer doesn't understand those letters. All the computer understands is electric signals. So remember, the computer is an electronic machine. It understands just signals. A signal is on or a signal is off. And so in computer language, if something is on, a signal is on, we represent that with the number 1. And if there is no signal, a signal is off, we represent that with the number 0. And so 0 and 1, this is the alphabet of the computer language. Those are the two only kind of, can say, letters that the computer understands. Well, they're not called letters, they are called bits. So 0 is a bit and 1 is a bit. Now, 0 and 1, those are just the little bits. You can't really represent a lot of things with bits. So if I want to store the letter I, how many bits do I need? Well, I need 8 bits. So every one of these letters, characters that I want to store, I need 8 bits. So 8 bits have a special name, which is byte, 1 byte. And so when you go and you start looking at RAM and they tell you RAM, you know, you have RAM of 8 gigabytes. This is the bytes that we're talking about, this little 8 little bits. And so our RAM is broken up into bytes. When we want to store information, we are storing information. We go and we say, oh, I want 1 byte, I want 2 bytes. So if you're storing a character, you just want 1 byte. Now, what's a giga? So let's start with kilo. So remember, kilo is 1,000. So when we say kilobyte, that's about 1,000 bytes. About, I'm going to say about because it's not exactly, about. When we say 1 megabyte, that's about 1,000 kilobytes. So we're talking about now 1,000,000 bytes. When we go to 1 gigabyte, we are talking about 1,000 mega. So every time we move to a new level, like from kilo to mega to giga, we're talking about 1,000, about 1,000 of the one before it. So when we say a gigabyte, we're talking about 1,000 megabytes, which means we're talking about we're talking about 1 billion bytes. So imagine RAM that has 1 billion boxes that you can store information in. And when we talk about 1 terabyte, because now hard drives, we talk about terabytes, we're talking about 1,000 gigabytes. Okay. So those are the explanations of the definitions of the those symbols that come after the number when we're talking about RAM and hard drive. So what I want to talk about now is when we want to store information in a program, how are we going to store this information? So we are going to store information in things called variables. We're going to go to RAM, we're going to request space from RAM, and we're going to store information there. So we need some space in RAM. We need a name for this space in RAM, so that when I go to RAM and I say, here, store the age of the person or store the name of the person, I can later come and say, give me back the name of the person or give me back their age. So when we're storing information, we need a way to refer to them, a name to refer to them. So those are called identifiers. Now, when we're choosing names for our identifiers for those variables or for things like the Java file that we created, like the project file, like Hello World, we need to have some rules. So the first rule is that there must not be any spaces. So when I was creating the Hello World project, I could not make it Hello Space World. That will not be allowed. So spaces are not allowed in names. Now, those names also cannot be reserved words. So if you look at the program that we wrote a little bit ago, there are some words that show up in blue, like public, class, static, void. Those are words that have special meanings in Java. And if a word has a special meaning, I cannot use it to name anything. So I can't come and name my Java file public.java, class.java, static.java. So when you're choosing a name, number one, make sure it does not have any spaces. Number two, make sure it's not one of those blue words. It's not a reserved word. The names can contain letters. They can contain digits. So you can have like 0, 1, 2, 3. They can contain the underscore, and the underscore, if you look on your keyboard after the numbers 890, and then there's like the dash, and then if you do shift, you get the underscore. So it can contain these. Identifier names are case sensitive. So hello with an uppercase H, hello with a lowercase h are not the same. When we're creating those names, we need to pick some meaningful names. So if you're talking about like someone's grade, you might create a variable or a class called grade. So all these are good meaningful names like X, like maybe X and Y, hello world, grade, side one, underscore is a valid variable character. They cannot start with numbers. I can't have a variable or an identifier that starts with a number, and I'll show you that in a little bit. So now that we know how to name things, why do we need variables? So we said we need variables to store information. So I might be writing a program that calculates how much a person needs to pay at a grocery store. So I might have a variable that represents how many items they bought. So like I'll have int bought equals 5, and we'll talk about what int means in a second. Maybe they bought things and everything, each item they bought is $2.99. So I'm going to come here and I'm going to say, well, the price of one is $2.99. And so maybe then I'll do a calculation and say, well, if they bought 5 and each one was $2.99, then 5 times $2.99 is the price that they need to pay. So those are variables. Now, when we're creating those variables, we need to think a little about what type of information we're going to be storing. So Java provides us with something called primitive data types, and there are 8 primitive data types that are built into Java. So they are byte, short, int, long, float, double, boolean, and char, and we'll go over all of them today, and we'll keep repeating those every class until you have them memorized. Okay. And this is a basic summary of all those bytes. So what is the difference between all these data types? So the first thing is I have to ask myself, if I'm going to be storing a number, I have to ask myself, is this number a whole number that I'm going to be storing, or is it going to be a decimal number? And a decimal number, we say it's a floating point number. So if I want to be storing something like 5, 100, a million, this is a whole number. I'm not expecting that it's going to have 0.5 or 0.07. So if I'm choosing to store a whole number, I have 4 choices. I have byte, short, int, and long. And so how do I decide which one I need to store my variable in? Well, the first thing I want you to notice is that storage-wise, they take different amounts of spaces. So if you say something is a byte, you're going to go to RAM and you're going to just get 1 byte. You're going to just get 1 box in RAM. If you say I want a short, RAM is going to say, oh, well, they want a bigger number. So I'm going to give you 2 bytes. I'm going to give you 2 blocks in RAM. If you want an int, you're going to get 4 bytes in RAM. And if you say I want a long, you're going to get 8 bytes. So obviously, if you have more storage, you can store a bigger number. So a byte can store whole numbers in the range between -128 to 127. Now, again, I'm not expecting you to memorize these numbers. Just know it's about 100. So if you have a number up to about 100, you might want to store it in a byte, like someone's age, for example, or how many students are in the Java 1 class. We only have about 24 students, so we only need a byte to store that information. Now, if I want to store a bigger number, like how many students are at MCC, or maybe the salary of a student at MCC, I might need a short. Okay, and here we're talking about whole numbers, so it's between -32,000 to 32,000. So if I'm storing some whole number in that range, I'll use a short. If I need a bigger number, I need an int, and then maybe I need an even bigger number, I might go to a long. So depending on the number that you need to store, you'll choose one of those data types. Now, the one that we're going to be using the most is int. And that's the one that is used mostly in books, because as you can see, you're talking now here about 2 billion. A range of -2 billion to +2 billion. That is usually enough for any application. So the most general data type that we're going to be using for whole numbers is an int. So byte, short, int, and long are for whole numbers. Now, if I want to store someone's salary, I might need to go to a float. So a float and a double, they are used for decimal numbers. A float requires 4 bytes of storage. A double requires 8 bytes of storage. Now, what is the main difference between float and double? It's precision. How much precision. How many significant digits do you want in your number? So if you're okay with 7 significant digits, go with a float. And that's the most general one that we're going to be using. Now, if you want more digits of precision, like you're dealing with, you know, something like the stock market or some small data, and you need to know like exactly how small the atom is, you need to go to 15 significant digits. But in general, a float will just do. Remember, every time you choose a type that you really don't need that storage amount in, you're wasting space. So if I say, oh, well, I just want to be on the safe side, I'm going to create all my variables as long. Well, if you can store it in 2 bytes and you use 8 bytes, you just wasted 6 bytes. Now, no one wants to buy a program or install software that just uses up all the RAM space, because RAM is expensive. So you need to be conscious when you're choosing what type of data type you're using, because you don't want to really waste RAM. On one hand, you don't want to waste RAM. On the other hand, you need to make sure that your data type is going to support what you want to store. So those are for numbers. So if I want whole numbers, I have byte, short, int, and long. If I want to store a decimal number, I have float and double. If I want to store a single character, I'll use char, like the middle character in my name or the first letter of my name. And if I want to store something called Boolean, which is true or false, yes or no, was Minnie Mouse absent today? Was there class today? Is there enough money in the bank to buy an item? I would use a Boolean to store that. And every one of these we're going to go over more in details in the next video.